A revision is just another step towards perfection. A warm good morning to one and all present here. I, Mr. Shashikiran Acharya, class coordinator for 2nd PUC revision classes, welcome you all to the free online crash course. It takes immense pleasure to introduce today's esteemed faculty for statistics, Mrs. Akshata. Mrs. Akshata has more than 15 years of teaching experience in statistics for 1st PUC and 2nd PUC. She has served as a statistics lecturer since 2008 to 2021 in Victoria Girls PU College, Mangalore. At present, she is working as stats lecturer in Shakti PU College. She has been taking class for CA Foundation from last 2 years and also has more than 12 years of experience in 2nd PUC board valuation. No doubt that she is one of the best lecturers in statistics. I welcome you to the session. Welcome.
Thank you.
I would also like to welcome all the enthusiastic and determined students who has gathered in this platform. So let's start with the session without any further delay. I request participants to rename yourself. Over to you. Thank you.
Yes, thank you. Good morning. Good morning, dear students. And thank you for that introduction, sir. So let us start the session. So let us discuss the blueprint first. I hope the blueprint is visible. One second. Okay. Excuse me. Minimize ಮಾಡುವುದೇಗೆ? Yes. So let us start the session, dear students. I hope you have the blueprint with you. And is this blueprint visible to you? Is it visible? Yes. Okay. So we have the chapters: vital statistics, index number, time series, interpolation, extrapolation, theoretical distribution, statistical inference, statistical quality control, and operation research. So as you know, your question paper is of 80 marks. So let us see few strategies which will help you in scoring maybe 80 out of 80 in the paper. Okay? Yes. So the first chapter is vital statistics. So the total weightage for this chapter is 13 marks. Okay? So 13 marks. So you can expect one question in the MCQ for 1 mark. Under match the following, you can expect one question. Roman number 4, one word. The first question will be from this chapter and a 10 mark. One question for 10 marks. So altogether, it is 13 marks. Okay. So it is 13 marks. One second. So next chapter is index number. Again, the total weightage is 18 marks. Time series, 13 marks. Interpolation, extrapolation, 7 marks. Theoretical distribution, 23. Inference, again 23. Statistical quality control, 8 marks. And operation research, you can expect questions for 21 marks. Total weightage will be 21 marks. Now let us go back to the first chapter, that is vital statistics. So the question numbers will be from vital statistics, question number 1, question number 11, question number 16, and question number 41. Okay, so from chapter 1. So these question numbers will be related to chapter 1, vital statistics. Okay, next index number. Okay, the question numbers would be question number 2, question number 6, question number 12, question number 29, and question number 42. So that is from chapter 2. Then we have time series, the third chapter. So question number 17, you can see the distribution. Question number 17. The first question under Roman number 4, question number 17 for 1 mark. Question number 21, that is 1 2-mark question, the first question under section B. And then question number 43. Okay, so from chapter 3, that is time series. Then we have chapter 4, that is interpolation, extrapolation. So question numbers would be question number 22 and question number 30 from chapter 4, interpolation and extrapolation. Okay, chapter 4, interpolation and extrapolation. Then we have inference and then theoretical distribution, which I will discuss later. We'll move on to the last topic, that is OR, operation research, where we have 5 units in that. That is, we have LPP, we have game theory, we have replacement theory, we have inventory theory, and then we have transportation problem. Okay, total weightage is 21 marks, and the question numbers would be question number 5, question number 10, question number 15 in the question paper, question number 20, question number 28, question number 35, and question number 36. So altogether 21 marks. See, many students find theoretical distribution and then statistical inference difficult. Okay, many of them. So if suppose you study, for those students I'm telling, if suppose you study these many chapters, that is the first chapter vital statistics, chapter 2 index number, time series, interpolation, extrapolation, and then the OR concepts, you can score a maximum of 72 marks. Okay, not 80, but 72 marks. But you should study everything, including the theory as well as the problems from these 5 chapters. Okay. So this is about your blueprint, how the questions are distributed in the question paper. Now let us see the model paper. I have taken one model paper. Okay. So your exam will be for 3 hours, 15 minutes. And let us see the instructions that is given in the question paper. So scientific calculators are allowed. See the 4th point here. Only the first written answers will be considered in section A. Okay, so under section A, either you can write in the first, or once you finish all the sums, you can answer these questions under section A at the end. But you have to, answers will be considered whatever it is written first. Don't strike out any answer. So think and answers. Think and answer. Okay. So section A, Roman number 1 is choose the correct answer from the choices given below. 5 questions will be given. 5 questions will be given. As I told you, first question is from vital statistics. Second question will be from index number. Third question will be from theoretical distribution. Fourth question will be from statistical inference. The fifth question will be from OR. Okay. It could be from game theory. It could be from inventory, replacement theory, LPP, or it could be from transportation problem. From any of the 5 chapters, they may select one and they can give the question there. That is for question number 5. Next, coming to Roman number 2, we have fill in the blanks. We have 5 questions there. So first question is from index number chapter. Second question is from theoretical distribution. Third question is from inference. Fourth question is from SQC, statistical quality control. Okay, I forgot to tell you about statistical quality control. So the total weightage will be 8 marks. Okay, 1 question for 1 mark, 1 question for 2 marks, and 1 question for 5 marks. Okay. Then coming to the 5th question under Roman number 2 is again from OR. I hope I'm audible. Roman number 3 is match the following, dear students. Roman number 3 is match the following, where the first question is from vital statistics. Second question is from index number. Third is from theoretical distribution. Fourth question is from inference. The last is again from OR. Okay. So section Roman number 4, we have answer the following. 1 word or 1 sentence. First question is from vital statistics. Second is from index number. Time series. Third question is from theoretical distribution. Fourth question is from statistical inference. And the last is from OR. So you can expect questions from inference, theoretical distribution, and OR from under each section, under each Roman number. Okay. Coming to section B. We have first question from time series. Now 2 marks, dear students. Out of 8, you have to answer any 5. 8 questions will be given, out of which you have to answer any 5. So you have to make the strategies from which chapters you are going to study the theory questions for 2 marks. Okay, so the first question is from time series. Okay, first theory question would be from time series. Second question is from interpolation, extrapolation. And as you know, students, from interpolation, extrapolation, there are 4 possible questions. It's a small unit. I think you can study all the 4 questions for 2 marks from interpolation, extrapolation, even from time series. Okay. The third question is from theoretical distribution. It could be from binomial distribution, could be from Bernoulli, it could be from Poisson distribution, it could be from hypergeometric distribution, or maybe from T distribution and chi-square. Could be from normal distribution also. So question number 24 is again from theoretical distribution. Question number 25 and question number 26 is from inference. Okay. Question number 23 and 24 is from theoretical distribution. Question number 27 is from SQC, which is again easy for most of the students. And the last question is from OR. Again, it could be from any of the 5 chapters that is given under OR. So this is section B, where out of 8, you have to answer any 5 questions. Now moving on to section C, students, under Roman number 6, 8 questions will be given for which you have to answer any 4. Okay, out of 8, you have to answer any 4. So first question is from index number. Okay, first question is from index number. Now, what are the questions? Make a note of this. Make a note of this. What are the questions that you can expect for question number 29 under Roman number C? It could be finding geometric mean index number, both weighted as well as unweighted. Weighted as well as unweighted index number. Or it could be consumer price index number. Or it could be last Pierce or past chase or Kelly's either price index number or it could be quantity index number. It could be simple arithmetic mean also, but very rarely they have asked. But more chances are for these questions when it comes to problems. Okay? Then you can expect theory questions here, that is from index number. It could be steps in construction of price index number or general index number, or it could be consumer price index number, steps in construction of consumer price index numbers. So these are the possible questions for question number 28, which is from the chapter index number. Okay, that is question number 29. Then coming to question number 30, it is from interpolation, extrapolation. And as you all know, dear students, we have only 2 methods over there. Binomial method, binomial expansion method, and Newton's forward difference method. So you can expect any of the 2 formulas there for the given data. Okay, that is for question number 30. Now here I'm discussing the questions, possible questions that you can expect for the second PU board exam. Once I finish with this, I will discuss the problems and the theory questions maybe. And if there is any doubt in any of the concept, you can ask. I'll help in clarifying those doubts, whatever it is there. Okay, so let me continue. Question number 31 and question number 32. Question number 31 and question number 32 is from theoretical distribution. Theoretical distribution for 5 marks. And what are the possible questions or possibilities for question number 31 and 32? Most of the times so far, it is always the sums that is asked, finding probabilities from discrete distributions. That is, it could be either from binomial distribution, it could be from Poisson distribution, or it could be from hypergeometric distribution. It could be the features also, any 5 features, or a sum related to finding the probabilities based on binomial or Poisson or hypergeometric. That is question number 31 and 33. So as I told you, under section C, out of 8, you have to answer any 4. So for those students, as I told, most of the commerce students will find theoretical distribution and inference chapter, not all, but few of them or most of them maybe. Okay, they find theoretical and inference difficult. So for them, for those students, you can be thorough with the index number and interpolation, extrapolation sum. And then you can study the OR concepts. OR concepts for question number 35 and 36. Okay. Moving back to question number 33 and question number 34. Now question number 33 3 and 34 is from inference, statistical inference. It could be a sum from large sample test. It could be from small sample test, or it could be from chi-square test. Question number 33 and question number 34. That is from the chapter statistical inference. Now, the last two questions, as I told you, question number 35 and 36 is from OR. Now, question number 35 could be a sum from transportation problem. How many methods do we have? Yes, ma'am, can you repeat 31 and 32? Yes. Yes, Simran. Question number 31 and question number 32 are from theoretical distribution. You can expect two questions from theoretical distribution. And as I told, it could be a sum or to write features or characteristics of the discrete distributions. How many discrete distributions do we have, dear students? Altogether, you have studied 4 discrete distribution. So Bernoulli distribution, very rarely they have asked because we don't have lengthy sums over there, which could be asked for 5 marks. So you can expect a question from binomial, Poisson, and hypergeometric. Binomial, Poisson, and hypergeometric distribution. From these 3 distributions, you can expect 2 questions. I hope your doubt is clear. Yes. So moving to question number 35 and 36, I was discussing about question number 35. So question number 35, it could be either from transportation problem or it could be from game theory. Okay, so in both the concepts, we have 2 methods. Under transportation, we have northwest corner rule, and then we have matrix minima method or least cost entry method. So any of the 2 methods could be asked over there. So either from transportation or it could be from game theory, where under game theory, again, we have 2 rules, that is maximin and minimax method as well as dominance rule. So question number 35, it could be either from transportation problem or it could be from game theory. And coming to the last question, that is question number 36, it could be a question from a replacement theory or a question from inventory theory. So now you have to make the strategies which are those chapters which you will be studying in order to clear the section C so that you can score a maximum of 20 marks. Now, those who find inference and theoretical distribution, my suggestion would be to study question number 29 and 30, that is from index number, all the possible questions, whatever I have written there, geometric mean index number, both weighted and unweighted. It could be consumer price index number. It could be the price index number or quantity index number for Laspierre, Pasteur's or Kelly's, or it could be steps in construction of consumer price index number, or it could be general price index number. That is for question number 29. Question number 30 is from interpolation, extrapolation, that you can study because both the methods are very simple and it is easy. Okay. And study the last 2 questions, that is question number 35 and question number 36, that is from OR, where the methods are very simple and the sums are scoring. Okay, remember, dear students, you have to write all the related formulas whenever you solve any sum where the values, the required values you are finding. Okay, the related formulas, so that you can score a full 5 marks in each sum, whatever you attempt. I suppose I'm clear with section C. Okay, now moving on to Roman number 7 in the same section. 4 questions will be asked for which you have to answer any 2. Out of 4, you have to answer any 2 questions. Now let us see what strategies you can make so that again you solve both the sums here. Okay, question number 37, dear students, it is always from normal distribution most of the time. normal distribution. That is from theoretical distribution. From theoretical distribution. It could be to write the 5 features or characteristics of normal distribution, or it could be to find the probability or the percentage or the proportion related to normal distribution. Okay. But the sum question number 37 is from normal distribution. Now question number 38 and question number 39 is from, sorry, not question number 39. I'm very sorry. Question number 38 is from inference. So altogether we have 10 sets of test statistics, 4 from large sample test, mean test we have 2, proportion test we have 2 formulas. Then we have small sample test, that is 3 tests to test for the mean values when the sample size is less than 30. And then we have chi-square distribution, where again we have 3 more formulas. So altogether you have 10 formulas. So out of the 10, any one test statistic, any one sum, any one data related to any of the test statistic could be asked there. Question number 38. Question number 39 is always from SQC. How many charts do we have under SQC, Statistical Quality Control? Yes, dear students, how many charts do we have under SQC? Yes, it is 4 charts. Out of the 4, you can expect any one chart there. Either it could be X bar chart, mean chart. It could be the range chart. It could be the chart for testing defectives. Which chart is used to test for defectives? Can I have an answer? Which chart do we use to test for defectives? Defectives. Defectives, it is NP chart. When it is defects, it is C chart, where Poisson distribution is considered. And hence, whenever defects are given, it will be C chart. Now, out of the 4 charts that we have, you can expect any one chart. Again, under those 4 charts, we have 2 sets of formulas when standards are given and when standards are not given. When the data is given, when we find the statistics, it will be standards unknown. So out of the 8 sets, you can expect any one set of formulas for question number 39. I suppose I'm clear. Moving on to the last question, that is 40th, question number 40. It is always from LPP. There is 95% chance that the question is from LPP. It could be a graph or it could be to formulate an LPP. Most of the times, again, 95% chance that it could be LPP to find out the feasible region if it is present in the given problem. Yes. So as I told in this section, that is section C under Roman number 7, you have to answer any 2. So my suggestion would be to study the normal distribution sum. Question number 39 you can study, and you can study the last question, that is question number 40. Question number 38, as I told, there are 10 sets of test statistics. Any one could be asked in. And those students, those who are thorough and for whom the test statistic is easy to identify, you can study all the formulas over there. You can attempt question number 38 also. So again, one more suggestion is that always in when you prepare for the board exam, under each section, if out of 8 you are answering any 4, study at least 5 and go, so that you attempt an extra question over there. We do not know which question will help us in fetching full marks and where we lose marks. Okay, so it's better to write an extra, answer an extra question whenever we write the board exam. That would be my suggestion. So that is regarding Roman number 7. Okay, moving on to the section D, that is the last section, and section which will help you in scoring more marks, that is Roman number 8. Easily you can score 20 out of 20 here. Out of the 3 questions given, the first question is from the first chapter, Vital Statistics. Second question is from the second chapter, Index Number. The third question is from the third chapter, Time Series. Now, moving to question number 41, that is the first question. What are the possible questions that you can expect here? So it could be a question from standardized death rate, finding STDR for when two localities or two populations are given. One full question for 10 marks. It could be from reproduction rates, finding gross reproduction rate and net reproduction rate. One full sum for 10 marks. Or you can expect two divisions under question number 41. That is 5 plus 5. It could be GRR or it could be NRR. As you see in this model paper, that is Roman number A, or it could be to find total fertility rate, or it could be to find CBR, GFR, ASFR. Possibility is there. Okay. But chances are more for asking GRR or NRR and TFR. But there is chance that even the crude birth rate, general fertility rate, and age-specific fertility rate question could be asked when they divide question number 41 as 5 plus 5. Okay? Yes. So these are the possible questions for the first division under question number 41A. Now B. Okay, for another 5 marks, most of the time they have asked a standardized death rate, where if you see this question in this model paper, death per 1,000 is given. See the data, death per 1,000 or whenever death rate is given, ASDR values will be given to us. A standard population will be given to you. Your duty will be to find PA and PB and find the standardized death rate for both the villages or localities, whatever it is given to you. Or it could be to find standardized death rate for one set of data, that is for one population. Okay, that is question number 41B, the second division there. Okay, yes. Any doubt under question number 41? So these are the possibilities. Okay, yes. Moving on to question number 42. Now, question number 42 is from index number, where you can see in this model paper, it is Fisher's index number and verifying time reversal test and factor reversal test. You have to verify time reversal test and factor reversal test. Or it could be to calculate Marshall-Edgeworth's index number and verify time reversal test. It could be to find any of the 5 out of the 5 index number formulas or methods that we have. They may ask any 2 formulas or any 3 formulas, like it could be Laspier's, it could be Paget's, it could be Dorbish-Bowley's, it could be Marshall-Edgeworth's, it could be Fisher's also, both price index number or it could be quantity index number. Okay, 3 possibilities for question number 42. 3 possibilities for question number 42, that is Fisher's index number and verifying TRT, FRT, Marshall-Edgeworth's index number, verifying time reversal test, or it could be to find any of the 3 or 2 index number formulas for the given data. That is question number 42. Moving on to question number 43, it could be one sum, full sum for that is to fit a parabolic trend or a second degree equation, that is y is equal to a plus bx plus cx square for 10 marks. Or it could be as it was given in this model paper, say finding moving averages for 5 marks and then fitting a least straight line trend or a linear trend, or it could be an exponential trend also. Okay, so that is question number 43. I think you can study all the 3 questions here. You can be thorough with all the 3 questions under section D. Now, this is how the questions are distributed in the question paper. Okay, so the maximum mark is 80. Maximum score is 80. Now, as I told in the beginning of the session, if you skip, now for those students who find theoretical and inference, where both the chapters are easy to score marks, If suppose, if at all you find that those two chapters are difficult for those students, you can study the remaining chapters and you can score 72 in the subject, including the theory questions. If you study the theory questions, you can score a maximum of 72 marks in the subject. But my expectation is that you score full marks in statistics because it's a scoring subject. Yes. Now, shall we solve the model paper? Or do you want me to discuss any chapters? Yes, dear students. Yes, okay. So let us discuss the model paper. Okay. So section A, choose the correct answer. The first question, the capacity of a woman to bear children is called? What is the answer? Yes? Fecundity, yes. Second question, the condition for time reversal test. Reversing the time, base to current and current to base. Time reversal test. Time reversal test. Option A. Question number 3. Binomial distribution if NP is 3, then the relation between mean and mode. NP is 3. NP is an integer. Yes, mean will be equal to mode if NP is an integer. In the following 4 statements, size of the test is probability of type 1 error. Power of the test is probability of type 2 error. Size of the test is 1 minus probability of type 1 error. Power of a test is 1 minus probability of type 2 error. The correct statements are 1 and 3, 1 and 4, 2 and 3, 2 and 4. Yes. So size of the test is, what is size of the test? Size of the test is probability of rejecting H naught when it is true. Size of the test. So probability of type 1 error. Rejecting H naught when it is true is type 1 error. Power of the test. Power of the test is probability of rejecting H naught when it is not true. When it is not true. When it is not true. That is 1 minus probability of type 2 error. That is 1 minus beta. Okay. Yes, Nishal. Option B is right. The last question, a game is said to be fair. A game is said to be fair when there is no gain and there is no loss. Value of the game will be 0. Option D, yes. Roman number 2, fill in the blanks. First question is from index number. Index numbers are specialized type of averages. Specialized type of averages, yes. Now, last year, you had studied about a few averages like mean, median, mode, geometric mean, and harmonic mean, where there was one rule that whenever the data is given to us, the units of measurement should be same. Whereas when we consider index number is an average where the units of measurement need not have to be same. So it is called as specialized type of averages. Next question, in chi-square distribution, if variance is 10, mean will be? Mean of chi-square is? What is mean of chi-square distribution? T and chi-square distribution is very important, dear students. Go through the formulas for mean, variance, and mode for chi-square distribution and T distribution. You can expect one question either from T or from chi-square. Okay, that's 100% question to be asked. Maybe from T or from chi-square related to mean, a variance or SD or even mode maybe. So mean of a chi-square distribution is, what is mean of chi-square distribution? N, very good. What is the variance? What is the variance of chi-square distribution? 2n. Now in this case, variance is given as 10. They are asking us to find the mean, which is n. What is n then? Mean. Yes, it is 5. 10 by 2, that is 5. Okay, ninth question is from SQC. SQC, a small amount of variation for which no specific cause can be attributed is called dash cause of variation. What are the two types of variation that you can expect? Yes, in this case it is chance. In this case it is chance. Chance, correct. Which is random in nature. The last question from OR. In this case, it is from inventory. Inventory reduces the dash cost. Which cost? Inventory reduces setup cost. Very good. I usually tell my students, few of them will be lazy to study the theory questions with them. To clear Roman number 2, one strategy that you can make is, it will not work always, but search for the words that come in the same chapter. Okay. So since the options are given to you, answers are given to you, from the available answer, you have to select the right one. Okay. So you can use that trick here. Again, you should make a note that it will not work always. Okay. Yes. Roman number 3, that is match the following. Roman number 3 match the following. First question is from vital statistics. Size of the cohort. Cohort is a group of individuals. Size of the cohort will be radix. Correct. Size of the cohort is radix. Retail price of the commodities. Index number chapter. Where do we use? Index number tells us the variation in the prices. Okay. Retail prices of commodities are used in cost of living index number. Cost of living index number. Yes. CPI. Mean of T distribution. See, I told you, you can expect questions from T and chi-square. Mean of T distribution. It is symmetric distribution. Okay, we have a peaked curve, symmetric curve, which is leptokurtic. What is the mean? It is 0. Mean median mode will be 0, right, for T distribution. Question number 14, inference. Hypothesis is given, alternative hypothesis. Mean is less than 10. What should be the null hypothesis? It is always equal. Mu is equal to 10. Question number 14. Matrix minima method. Which chapter? Matrix minima method. Transportation problem. Transportation problem. Yes. Roman number 4. Roman number 4. Write the formula for estimating the population between census years. What is the formula? What is the formula? P naught plus B minus D plus I minus E. Name the graph used in representing time series data. What is the graph that we use? The graph is called as histogram, right? Histogram. A range for T distribution. A bell-shaped curve. Range. A range for T distribution. Minus infinity to plus infinity. Yes. Define alternative hypothesis. We state two hypotheses whenever we test. Okay, that is null hypothesis and alternative hypothesis. Alternative hypothesis is a statement which is accepted when the null hypothesis is rejected. Okay, that is alternative hypothesis. Yes. What is meant by maximin? Maximin. Maximin is maximum of row minimums. Okay, game theory. Maximum of row minimums. Yes. Section B, maximum of rho minimum. Right. Section B, question number 21. Mention a cause for the following variation in time series. You have to mention the cause, seasonal variation. We have two causes. Seasonal variation. Can you give me the answer? Weather conditions, customs, traditions, and habits of the people. Anyone you should mention. Irregular variation. Irregular variation. It's a sudden variation. Yes, natural disaster. Right. Two conditions for application of binomial expansion method of interpolation and extrapolation. Two conditions. So as I told you, for question number 22, there are only 4 possibilities. It could be assumptions for interpolation, extrapolations, the condition for application of binomial expansion method, or define interpolation, extrapolation, or what are the methods of interpolation, extrapolation. So 4 possibilities. Out of the 4, you can expect any one there for question number 22. Now question number 23. Question number 23. Q is given as 0.4. You have to find variance of Bernoulli distribution. What is the variance for Bernoulli distribution? What is the variance? Bernoulli distribution. Can I get the formula? Variance. Variance is PQ. Q is given as 0.4. Q is given as 0.4. What will be P? 1 minus Q. Yes, Michelle. P will be 1 minus Q. So our P will be 0.6. What is 0.6 into 0.4? Yes, 0.24 is the answer. 0.24 is the answer. Right. Question number 24 is again from theoretical distribution. In a Poisson distribution, if mean is 9, find the standard deviation. Mean is 9 for Poisson distribution. Mean is lambda. For Poisson distribution, variance is also equal to lambda. Correct. So standard deviation is root variance. So root lambda, root 9 is 3. Right. So one more question. Name the distribution for which variance and mean are same or equal. Your answer will be Poisson distribution. Question number 25 is from inference. Question number, yes, correct. Question number 25 is from inference. Sample size N1 is given as 80, N2 is given as 40, P1 is 0.8, P2 is 0.4. They are asking us to find the standard error for the difference in the proportion. Standard error for difference in the proportion, population proportion. So we have the formula as P1 Q1 by N1 plus P2 Q2 by N2. Use the formula, substitute and find the answer. Okay. Q1 will be 1 minus P1, that is 0.2. P2 will be 1 minus 0.4, that is 0.6. Okay, so 0.8 into 0.6, 0.2 by 80 plus 0.4 into 0.6 divided by 40. Yes, define estimator and estimate. Estimator and estimate from again inference. Estimator and estimate. Question number 27 is from SQC. X bar dash is given to you. X bar dash, which is 15. Sigma dash is given as 2. Okay, X bar dash and sigma dash. They're asking you to find the upper control limit for X bar chart. What is the formula? X bar chart, the upper control limit will be X bar dash plus A sigma dash, right? A sigma dash. Yes, sample size is 4. So for n is equal to 4, you have to read the A value from the table. A value from the table for n is equal to 4. So for n is equal to 4, we have A as 1.500. Okay, 1.500. Substitute it and find the answer. X bar dash is given. X bar dash is given as 15, 1.500 into sigma dash, that is 2. So 15 plus the product. Okay, 15 plus the product, yes. Then we have question number 28. That is from replacement theory. Okay, replacement theory. So the question is, the depreciation cost and the cumulative maintenance cost for the fourth year is rupees 4,000 and 7,200. Compute the annual average cost, 2,800. Good. Krishna Prasad Kamath, 4,800. So we have A of n formula as P minus Sn plus sigma Ci divided by n. Substitute. P minus Sn will be the depreciation cost, which is given as 4,000. We have sum of Ci, which is given as 7,200, cumulative maintenance cost, divided by n, which is the year, which is 4. Okay. So you'll get the answer as 2,800. 2,800. Now, therefore, question number 28, as I told you, you can expect any question from the OR. In this case, they have asked a sum from a replacement theory. Okay. Then section C, question number 28. Simple geometric mean index number. Simple geometric mean index number. Okay. Simple geometric mean. So what is the formula to find simple geometric mean? Question number 29. Simple geometric mean index number. So it is anti-log of summation log P by N. Okay, summation log P by N. So this is our formula. This is our formula. So you have to find, prices are given. Check the data. Prices are given. The base year price 2021 P0. The current year price, that is for 2023, P1 is given. So you have to find P. How to find P? What is the formula? P is P1 by P0 into 100. Okay, price index. So find P, 25 divided by 20 into 100, 30 by 25 into 100, 25 by 30 into 100, 8 by 10 into 100. So you'll get the values. Find log P. Log P. Find the sum. Substitute and then find the answer. Question number 29. Okay. Question number 30. Interpolation and extrapolation. Newton's method. Newton's method is asked. And here, as I told you, there are two methods. Newton's method and then binomial expansion method. Now, how to identify whether it is Newton's method or binomial method? Sometimes they may not mention the method. Okay, which of the two methods you have to use for the given data? How will you identify? How will you identify whether it is binomial expansion method or Newton's forward difference method? Okay, so if a complete table is given without any missing value in the table, you have to go for Newton's forward difference method. If there is any missing value in between and at the end, if there are two missing values, then it is binomial expansion method. Okay, binomial expansion method and Newton's forward difference method. Okay. I have not left the space to solve the sums here. I'll take one more model paper where I have given some space. I hope it is okay. Is that okay with you, dear students? Okay. Yes, okay. So question number 30. I was discussing question number 30. As I told you, interpolation, extrapolation. In this case, yes, a complete table is given without a missing value. So which method do we use here? Which method do we use? It is Newton's method, yes. So X and Y, we write all the values and then we find the differences, delta 1, delta 2, delta 3 and so on, depending on the differences that is obtained. Okay. Do you want me to solve the sum? Or shall we solve sum related to theoretical distribution and inference? Yes, dear students. Yes. So theoretical distribution, question number 31. Theoretical distribution, question number 31. 40% of the buttons manufactured by a firm are found to be defective. In a random sample of 6 buttons, find the probability of getting exactly 4 defective buttons and more than 1 defective button. Okay. 40% of the buttons manufactured by a firm are found to be defective. In a random sample of 6 buttons, find the probability that there are exactly 4 defectives and more than 1 defective. Now, can you tell me which distribution is given? I told you question number 31 and 32 is from theoretical distribution and it could be either from binomial, Poisson or hypergeometric. Okay, so we have 3 types of distribution there, discrete, binomial, Poisson and hypergeometric distribution. Okay, hypergeometric distribution. One second. Okay, how many parameters do we have for binomial distribution? How many parameters do we have for binomial distribution? Yes, dear students, how many parameters? We have 2 parameters. Can you name the 2 parameters? What are the 2 parameters? N and P, right. Poisson distribution, how many parameters do we have? We have 1 parameter and it is lambda. Hypergeometric distribution, how many parameters do we have? We have 3 parameters. And what are the 3 parameters? Yes, it is A, B and N. Now from these 3 distribution, you can expect questions for question number 31 and 32. Now, for many students, it is difficult to identify the distribution, which mass function to be used, and for the given data, which distribution to be used, whether it is binomial or Poisson or hypergeometric. Now, what you can do is, for binomial distribution, we all know that it is 2 parameters, N and P. Now, when any data is given to us where there is a percentage value or a point value or a fraction value is given to us, okay, it is taken as P. Okay, chance of occurrence of the event is given to you, which is always a point value. It could be a percentage value. And the sample size N is given to you. Okay, sample size N is given. Now, in this case, if you read the question, 40% of the buttons manufactured by a firm are found to be defective. So there is chance that 40% of the buttons can be defective. And in a random sample of how many buttons? 6 buttons. So they have given us N. So whenever N is given to you, sample size N is given to us, either it could be binomial or it could be hypergeometric. Okay. So whenever N is given to you, sample size is given to you, it could be either binomial distribution or it could be hypergeometric distribution. Now, for a binomial distribution, we need the parameter P, which is a probability or a percentage value or a point value. Whereas for hypergeometric, 2 categories will be given to you. Okay, that is how you can differentiate between binomial distribution and hypergeometric distribution in the exam. Okay, yes. So in this case, Can you tell me which distribution it is? Since n is given, 6 buttons they have given to us. N, sample size n is given as 6. Either it could be binomial or it could be hypergeometric. Yes, it is. Yes, it is binomial distribution. So how do we solve the sum so that we can get full 5 marks? Write the parametric values. Okay, let us define x first. Let us define x first. Read the question. They are asking you to find some probability, and the probability is regarding defective buttons. Okay, exactly 4 defective buttons, more than 1 defective button. So based on the asked question, for which we have to find the probability, define your x. And whenever it is binomial, Poisson and hypergeometric, our x will be some number because it is discrete distribution where the values are obtained by counting process. Okay, so x will be some number. In this case, it is number of defective buttons. The data is related to defective buttons. Our x will be number of defective buttons. Name the distribution. X follows BD, binomial distribution with 2 parameters n and p. Let us write the parametric values. N is 6. P is always for x. It is P of x. The probability is for the x that you define. Okay. And our x is number of defective buttons. P is percentage or probability of defective buttons. What percentage is given to us? P is 0.4, right? Q will be the non-defective buttons. What is that proportion, percentage? If P is 0.4, Q will be 1 minus 4, that is 0.6. So your mass function carries 1 mark. Probability mass function, you have to write, it carries 1 mark. Okay. So what is the formula? NCX, P to the power X, Q to the power N minus X. So whenever you write the mass function, mention the range. In this case, 0, 1 to N, our N will be 6. Okay. So this carries 1 mark. Okay. Naming the distribution carries 1 mark along with writing the parametric values. Writing the formula carries 1 mark. Now let us find the probabilities. Okay. Probability. Sorry, exactly 4 defective buttons. Our X is number of defective buttons. N is given to us. P and Q is also given. X we have to substitute. So it is exactly 4 defective buttons. X is equal to 4, right? So X is 4. Substitute 4C 4. P is 0.4, 4 to the power 4. Q is 0.6 to the power n minus x, that is 4 minus 4. So 4C4 is 1. 0.4 to the power 4. What is the value? 0.4 to the power 4. Can you calculate and get the value? Give me the value. 0.4 to the power 4. 0.4 power 4 is 0.0256. Okay. I'm using scientific calculator. Otherwise, it is 0.4 into 0.4 into 0.4 into 4 minus 4 is 0, 0.6 power 0. Any number to the power 0 is always 1. So your probability is 0.0256. Exactly 4 defective button. Okay. Second question. More than 1 defective button. Probability x greater than 1. X greater than 1. What are the values taken by x now? In the previous case, it was x is equal to 4. X took only one value, that is 4. It was clearly mentioned there that x is 4. In this case, x is more than 4. What are the possibilities when x is greater than 4? X could be 2, or it could be 3 defective buttons, or 4 defective buttons, or 5, or 6. Altogether 6 buttons. Sample size is 6. Maximum number of defective button that is possible is 6. So when x is more than 1, it could be either 2 defective buttons, 3, 4, 5 or 6. So see the amount of calculation, how many times you have to use the mass function. So 1, 2, 3, 4 and 5. So 5 times you have to substitute your mass function. Instead, you can go for complement, that is 1 minus probability x less than or equal to 1. Okay? Less than or equal to 1. What are the values taken? What are the values taken? If x is less than or equal to 1, x can take value 0 or it can take value 1. So x is equal to 0 or x can be equal to 1. X can be equal to 1. Okay. So that is 1 minus 4c 0, 0.4 power 0, 0.6 power 4 minus 4 is 0, plus 4c1, 0.4 power 1, 0.6 power 4 minus 1, that is 3. So find the probabilities. Ma'am, their first sub question, q to the power n minus x, 6 minus 4. Yeah, very sorry. Yes, correct. I'm sorry, who is it? Mega. Sorry, n is 6. Correct, n is 6. N is 6. So 6 minus 4 will be 2. 0.6 power 2. That is into. Yes, correct. 0.6 power 2 will be 0.36, isn't it? What will be the answer then? 1 into 0.0256 into 0.36. So find that answer. Find the product. Okay, so that is how you find the probability for question number 31. Any doubt? 6C4. Yes, again it is 6C4, correct. I took n as 4 over there, correct. 6C0, 6C1. So x less than or equal to 1, 0.4 to the power 0, and 6 minus 0 is 6. Okay, in this case, 6 minus 1 is 5. Yes, is it correct? Yes. Okay, yes. Any doubt? A binomial distribution. Binomial distribution. Now, sometimes the question may be to find at least one defective button or at least 2 defective buttons. So whenever it is at least, x will be greater than or equal to 2. Okay, greater than or equal to 2. One example, if suppose our interest is to find the probability that there are at least 2 defective buttons, then x will be greater than or equal to 2. If suppose it is to find at most 2 defective buttons, it will be probability x less than or equal to 2. At least means greater than or equal to 2. At most means less than or equal to 2. Less than or equal to 2. Shall we move on to the next sum? Yes? Yes, question number 32. Question number 32. If there is any doubt, you can ask. Question number 32. There are 20 marbles in a box, out of which 12 are red colored and rest are white colored. A child picks 6 marbles at random. Find the probability that the child gets 4 red colored marbles. So 20 marbles. I told you, question number 31 and 32, again I'm repeating, it could be from binomial distribution, Poisson or hypergeometric. So which distribution is this? 20 marbles, out of which 12 are red and the rest are white. A child picks 6 marbles. How many marbles? 6 marbles. So n is given. So whenever n is given, either it could be binomial or hypergeometric. So for binomial, you can search for a point, fraction, or a percentage value. Then it will be binomial distribution. most of the times. Otherwise, when two categories are given, it will be hypergeometric distribution. That is how easily you can identify the distribution. Okay, so this is hypergeometric distribution. Very good. So what is our X? What is the question about? What is the question about? What probability are we interested in finding? So they are asking us to find the probability that child gets 4 red colored marbles. Yes. So our X will be number of red marbles or red colored marbles. So X follows hypergeometric distribution with 3 parameters A, B, and N. Now in this case, be careful. I've seen many students making mistakes. A, as in binomial distribution, I told you, P is for the X that you write. It is P of X. Okay, probability is for X what you write. In this case, A is with related to our random variable X. A will be number of red marbles given. How many red marbles are given? How many red marbles are given? 12. So A will be 12. B will be the remaining white colored marbles. Altogether 20 marbles, 8. N will be the number of marbles selected, sample size. How many marbles? 6. Correct. So this carries 1 mark. Okay, that carries 1 mark. Now let us find the probability. Okay, mass function. You have to write the probability mass function P of X. So we have ACX, BCN minus X plus A plus BCN. So what is the range for X? X can take values. It could be 0 red colored marble selected out of 6. It could be 1. It could be 2. Minimum of A and N. So our A is 12. N is 6. What is minimum of 12 and 6? It is 6. Yes, so the range would be 0, 1 to 6. 0, 1 to 6. Now, how many red marbles? 4 red marbles. 4 red marbles. So probability, number of red marbles, X will be 4. See, most of the times, dear students, under hypergeometric distribution, they have asked question where they will ask you to find the variance and mean or expected number of something. So whenever it is expectation, what are we supposed to find? Expected value of X is nothing but or hypergeometric any distribution it could be. Yes, E of X is what? What exactly you have to find over there? E of X is what? E of X is nothing but expected value of X is nothing but mean. Correct. And what is mean for hypergeometric distribution? What is the formula? It is NA by A plus B. Okay. Yes. Coming back to the sum, they are asking us to find, yes, they are asking us to find 4 red marbles. So let us substitute in a mass function. So whenever we find the probability, it is the mass functions that we use for binomial, Poisson, and hypergeometric to find the probabilities, chance of occurrences. Yes. So our A is 12. Our X is 4, 12C4 into B. B is 8, C, N minus X. N is 6. 6 minus 4. 6 minus 4 is 2, 8C2. A plus B. 12 plus 8 is 20 marbles. C is 6. So 12C4. Either you can go for the scientific calculators, 12C4 or split and write. 12C4 can be written as 12 into 11 into 10 into 9 divided by 4 into 3 into 2 into 1 or 4 factorial into 8C2 will be 8 into 7 by 2 into 1 divided by 20C6 will be 20 into 19 into 18 into 17 into 16 into 15 divided by 6 factorial, that is 6 into 5 into 4 into 3 into 2 into 1. So simplify and find the probabilities. Can you give me the answer? 12C4 into 8C2 divided by 20C6. So is it 0. Yes, 3576 is the answer. Any doubt? Any doubt regarding hypergeometric distribution? Okay, I told you regarding identifying either it is a binomial distribution or a hypergeometric distribution. For both, n will be given. If n is given, it will be either binomial or hypergeometric. Now, Poisson, how to identify Poisson distribution? Now, Poisson distribution are associated with the rare events. Okay, associated with the rare events where we cannot tell the exact number of occurrences. For example, number of persons visiting a doctor, or number of persons waiting in a queue, or number of vehicles parked in the parking lot. It is not same always. Or number of accidents, say on Tuesday, it is not same. It can be any number. So in such cases, we go for Poisson distribution, okay, where we have a parameter lambda, and lambda is average number of occurrences, or mean number of occurrences. So there is no sample size n. It is not possible to tell exactly what number of times the event will occur. Okay, so then it is considered as Poisson distribution. So whenever a question is given to you, there will not be a sample size n. N will not be given to you. And in such case, if you read the question, it will be average number of occurrences or mean number of occurrences. Okay, then it will be Poisson distribution. And Poisson distribution, the mass function is e power minus lambda, lambda power x by x factorial, where lambda is the mean occurrences or average occurrences. Okay, shall we move on? Yes. Shall we take a break? Yes, dear students. If there is any doubt, you can note down. After the break, you can clarify the doubt. Yes, any concept it may be. Okay, we will discuss the concepts. Yes, we'll meet after 10 minutes maybe. Okay? Yes. Thank you. Are you all there, students? Yes, shall we continue? Yes? Can I get a yes from your side? Are you all back? Yes, okay. So we were discussing question number 31 and 32, that is from theoretical distribution. Shall we discuss some more questions from that chapter, that is theoretical distribution? Shall we discuss few more sums? Yes, okay. Okay, so these are few sums that I've selected from theoretical distribution. And as I told, the question number is 31 and 32. Question 31 and 32. Okay. See the first question here. On an average, a typist makes 2 mistakes per page. On an average, a typist makes 2 mistakes per page. Find the probability a page typed by him has 2 mistakes, at most 1 mistake. Which distribution is this? Is it binomial? Is it Poisson? Is it hypergeometric distribution? What did I tell? Yes, it is Poisson distribution. I told you, whenever an average or mean value is given, and when the sample size n is not specified in the data, it is Poisson distribution. We have to go for Poisson distribution. So it is Poisson distribution. The data is related to, information is related to mistakes per page. What will be our x? What shall we define our x as? X will be number of mistakes per page. So number of mistakes. So this x follows Poisson distribution with one parameter, that is lambda, and lambda is the average number of mistakes in this case, or mean mistakes in this case. What is the average number of mistakes given to us? What is the average number of mistakes given? It is, on an average, how many mistakes? 2 mistakes. So lambda will be 2. So we write the mass function. Yes, 2 mistakes. We write the mass function e to the power minus lambda, lambda to the power x by x factorial, where x can be 0 mistake, 1 mistake, 2 mistake. It can be any number of mistakes. Okay, any number of mistakes. So the first probability that they are asking us to find is 2 mistakes. X will be 2. So in this case, it is e power minus 2. 2 to the power x. X will be 2 divided by x factorial, that is 2 factorial. So e power minus 2 can be read from the table, Poisson table, e power minus 2. Or using the scientific calculator, e to the power minus 2. So Poisson distribution table. Is the table visible? Okay, our x is 2. Our x is 2. So 2 under 0 it is 0.1353. 0.1353. So let us substitute. Okay, that is 0.1353 into 2 square is 4, divided by 2 factorial is 2 into 1, that is 2. So multiply and divide, you will get the probability, required probability. Yes, 0.1353. Yes, correct. 0.1353 into 4 by 2. 0.1353 into 4 by 2. So what is the answer? Is it 0.2706? Yes, 2706. At most one mistake. What did I tell? At least means whenever it is at least, it is greater than or equal to. At most means it will be less than or equal to. Left hand. Okay, your left hand, L, less. Okay, this symbol. When you face your palm, so it will be X less than or equal to 1. At most one mistake. So probability. What are the values taken? 0, 1, 2. Right. X could be 0 mistakes, or it could be 1 mistake, or it could be 2 mistake. Sorry. 0 and 1. Why 2, Nishil? At most 1, no? At most 1. So 0 and 1. Correct? 0 and 1. So it is e power minus 2, 2 power 0 by 0 factorial, plus e power minus 2, 2 power 1 by 1 factorial. So we can take e to the power minus 2 as a common term outside. Yes, 2 power 0, any number to the power 0 is 1. Any number to the power 0 is 1. 0 factorial is 1. 1 by 1 is 1. Plus 2 power 1 is 2. 2 power 1 is 2. 2 by 1 factorial is 2. Okay, so 1 plus 2. So e to the power minus 2 into 3. That is 0.1353 from the table, e power minus 2 into 3. What is our answer? What is our answer? 0.1353 into 3. So it is 0. Can I get the answer? 0.4059. 0.4059 will be the answer. Correct. Now, if suppose for the same data, if the question is to find at least one mistake, it's Poisson distribution. We don't have an upper bound over there. X can take any value. Okay. So if it is at least, it will be probability X greater than or equal to 1. X can take value. What are the values taken? If it is at least 1, yes, students, it can be 1, or it can be 2, it can be 3, it can be 4, it can be any value. It can be any value as there is no upper bound there. So we have to go for complement whenever it is Poisson. Yes. Yes. So it is not possible to get the probability there whenever it is greater than or equal to some value to be found, probability. Okay. So we have to go for the complement 1 minus probability X less than 1. So when it is greater than or equal to, when you take the complement, it will be less because the number 1 in this case is already included. When you take the complement, that 1 is excluded here. So 1 minus probability X less than 1 means what is the value taken? X will be 0. So 1 minus probability X is equal to 0. If for the same data, if the question was to find at least one mistake, okay, at least one mistake. So it will be 1 minus probability X less than 1. So the value taken by X will be 0. So that will be 1 minus e power minus 2, 2 power 0 by 0 factorial. So that is 1 minus 0.1353. 2 to the power 0 is 1, 0 factorial is 1. So 1 minus the probability, that is 0.1353 will be the answer. Any doubt? Any doubt? Okay. We'll move on to the next question. So see the next question over there. A box contains 8 red and 4 white balls. From this box, 5 balls are drawn. How many balls? 5 balls are drawn. What is the probability that the sample contains 3 red balls? 3 red balls. What distribution is this? A box contains 8 red and 4 white balls. 5 balls are drawn. Yes, hypergeometric distribution. N is given. Category 2 categories are given. So it is hypergeometric distribution. What will be our X? What is the probability that we are interested in finding? What is our X? X will be number of red balls, right? X will be number of red balls. So X follows hypergeometric distribution with three parameters A, B, and N. What is A? What is A? A is for X. Yes. A will be number of red marbles. In this case, it is 8 red marbles given. B will be number of white marbles. That is 4. N will be the sample selected, number of balls selected, 5. So they are asking you to find probability of 3 red balls. So mass function carries 1 mark, as I told you, ACX, BCN minus X by A plus BCN. So X ranges from 0, 1 to minimum of A and N. Minimum of A and N. A is 8, N is 5. Minimum is 5. Yes. So 0, 1 to 5. So the probability will be 3 red balls. X is equal to 3. X is equals to 3. So 8C3 into 4C 5 minus 3. N minus X. N is 5. X is 3. So 5 minus 3 will be 2. Divide by A plus B. 8 plus 4, 12. Cn. N is 5. Okay. So find the answer. 8C3 will be 8 into 7 into 6. Divide by 3 into 2 into 1 if you are using normal calculator. 4 into 3 by 2 into 1. Divide by 12 into 12C5. So 12 into 11 into 10 into 9 into 8. Divide by the 5 factorial. That is 5 into 4 into 3 into 2 into 1. So simplify and find the answer. Did you get the answer? Yes, 0.4242. Is that answer right? For the students, is that answer correct? 0.4242. Nishal has given the answer as 0.4242. Yes. We move on to the next question. Next question from the same chapter. In a college, okay, in a college, 35% students are girls. Find the probability that 2 are girls, at least 1 is a girl in a random sample of 5 students. What is the distribution? In a college, 35% students are girls. It is binomial distribution. Right, very good. Binomial distribution. Binomial distribution. What is our X? What shall we define our X as? What is the probability that we are interested in finding? X can be defined as number of girls. Yes, number of girls. So this X follows binomial distribution with 2 parameters, A, N and P. N will be number of students selected, sample size. How many students are selected? 5. N will be 5, correct. P is a probability of girls or proportion of girls, percentage of girls. What is P? What percentage of girls are given? 35%, that is 0.35. So Q will be the probability or the percentage of boys. That is 0.65, right. So we write the mass function. So that is NCX, P to the power X, Q to the power N minus X. X takes values from 0, 1 to N. In this case, our N is 5. So they're asking you to find the probability that 2 are girls. X is equal to 2. Number of girls is 2. So when X is 2, we use the mass function. 5C2 0.35 to the power 2, 0.65 to the power 5 minus 2, that is 3. What is the answer? Can I get the answer? 5C2. Yes. 5C2 into 0.35 put to the power 2, 0.65 to the power 3. So 5C2 into 0.35 to the power 2 into 0.65 to the power 3. So the answer is 0.3364. Is that right? Check. Are you getting the same answer? 5C2 will be 5 into 4 by 2 into 1. Yes, 3364. That is the answer. At least one girl. At least means at least greater than or equal to 1. What are the values taken? At least one girl. What are the values taken? X greater than or equal to 1. What are the values taken by X? Yes? X takes values 1, 2, or 3. Yes, correct. Or 4 or 5. Right. 4 or 5. Again, the calculation will be more. So we go for complement. 1 minus probability X less than 1. Now in this case, when X is less than 1, what is the value taken by X? It is 0. So X will be 0. Right. So 1 minus 5C0, 0.35 to the power 0, 0.65 to the power 5 minus 0, that is 5. Okay. So this is how we find the probability. When X is 0, 5C0, 0.35 to the power 0, 0.65 to the power 5. Okay, find the answer. Any doubt in this sum? Okay, we'll move on to the next question. Now, remember, dear students, especially in binomial distribution, okay, now for the same question, if the given data is in a college, say 35% students are boys, okay, 35% of the students are boys, find the probability that 2 are girls, at least 1 is a girl, in a random sample of 5 students. What will you define your X as? What will you define your X as? What is our X? Yes, Megha? Megha is having some doubt. What is it? Okay. Yes. In a college, 35% students are boys. Find the probability that 2 are girls, at least 1 is a girl in a random sample of 5 students. What will will you define your X as? What shall we define our X as? It is number of girls, right? Okay, it is number of girls because we are interested in finding the probability for the girls. Okay, so this follows binomial distribution with 2 parameters n and p. What is n? What is n? What will be our n? N is 5, right? P, as I told you, it is p of x. What is p? Your x is number of girls. P will be probability of girls. P will be probability of girls. In this case, what will be your P? What will be your P? Yes. So it is 0.65. So remember, in the exam, read the question properly. Read it properly and see the probability that we are interested in finding. Based on the probability that we are interested in finding, we define our X. Based on the X, we have to write the probability value. In this case, our X is number of girls, but the first data is given for boys. They are saying 35% of the students are boys. Okay, so our P is the probability or percentage of girls. So in this case, it will be 0.65. And Q is the probability of boys, which is given as 35%, that is 0.35. So be careful when such questions are asked. Okay, yes. Shall we move on to the next question? Shall we move on? I suppose I'm clear with binomial distribution. Okay. We'll go to the next question. State 5 properties of normal distribution. 5 properties of normal distribution. Can you tell me the 5 properties? The easy one, which we'll use to solve the sums. Yes? 5 properties. Who will give the answer? 5 properties. Any 5 properties for normal distribution. See, Roman number 7, section C, question number 37 is always for normal distribution, as I told you. It could be a sum or it could be to write 5 properties of normal distribution. Most of the times they have asked the application that is sum, and information is given how to standardize it and find the probability of the occurrences given to us. Now, can you tell me the 5 properties of normal distribution? So what you can write? It is a bell-shaped curve. Okay. Then, can you tell me the points of inflection? You can mention that points of inflection is mu minus sigma and mu plus sigma. Points of inflection. Yes, mean, median, mode are equal. Mean is equal to, median is equal to. Okay, then what else you can write? Can you write the formulas for quartile deviation and mean deviation? Anyhow, you have to study. If suppose a 2 mark or 1 mark question is asked, total area is equal to 1. Yes, correct. Total area is equal to 1. Total area is equal to 1. What is quartile deviation formula? Quartile deviation 2 by 3 sigma. Mean deviation 4 by 5 sigma. How do we find the quartiles? The lower quartile and the upper quartile? Lower quartile is mu minus 0.6745 sigma. And the upper quartile Q3 will be mu plus 0.6745 sigma. Okay. So those are the 5 points that you can study whenever they ask us to write 5 properties of normal distribution. Easy ones. Okay. Yes. We'll move on to the next question. Identify the distribution and tell me. Okay. Next question. So these will be question number 31 and 32 in the new model paper, according to the new model paper, 80 marks paper. Okay. So the probability of a thermometer manufactured by a firm is found to be defective is 0.02. Probability of a thermometer manufactured by a firm found to be defective is 0.02. Find the probability that a box containing 50 thermometers contain no defective ones. And among 1,000 such boxes, how many contain exactly 2 defective thermometers? What distribution is this? Why test? Yes, Shivu, why Z test? Are they asking us to test something? Is there a question mark? Yes, how many contain? Yes. But are they asking us to test something? They're asking us to find something. See, how many contain exactly 2 defective thermometers? And see, moreover, they are asking in the first question, find the probability. It is not Z test. It is not Z test. It is to find the probability. Okay? It is to find the probability. Distribution is binomial. Okay, it is binomial. What is your X defined as? What is your X defined as? Information is regarding defective thermometers. What shall we define X as? It is some number. In this case, it is defective thermometers. Number of defective thermometers. Yes, number of defective thermometers. And as you told, it is binomial distribution. I told you a point value is given, N is given, sample size N is given, number of thermometers is 50 given to us, N and P. So our N is 50, P is 0.02, P is 0.02. Is it a limiting form? Is it a limiting form? N is large, P is small. Remember, dear students, whenever a binomial distribution is given to you, okay, check for the probability p-value. If the p-value lies between 1% to 9%, okay, that is 0.01 to 0.09, we consider that, we say that p is very small. Okay, p is small. And check for the p-value first. If your p-value ranges from 1% to 9%, we assume that, we consider that probability is very small. Then we check our n value and we say, since p is small, okay, and n is large, yes, mega, binomial tends to Poisson distribution. Binomial tends to Poisson distribution. Now, even if you solve the sum considering it as binomial distribution, it is correct, but the calculation will be tedious. See, our n is 50. Okay, our n is 50. So if suppose you are finding, say it is binomial distribution, p of x, it is not wrong, it is correct. Okay, our binomial distribution mass function is ncx p power x q power n minus x. And your n is 50 here. 50 cx, 0.02 to the power x, 0.98, that is q, 1 minus 0.02 will be 50 minus x. Will be 50 minus x. And if suppose you are finding, let us say it is two thermometers, probability that there are exactly two defective thermometers. So it will be 50C2, 0.02 to the power 2 and 0.98 to the power 50 minus 2, that is 48. See the amount of calculation here. See the calculation. If when you are using scientific calculator, yes, you will get the answer. But otherwise, I am telling, the calculation will be tedious. So we convert the binomial distribution into Poisson distribution whenever n is large and p is small. That is, when it ranges from 0.01 to 0.09, that is 1% to 9%, p is always considered as small, and we convert binomial distribution to Poisson distribution. And for Poisson, how many parameters do we have? The same question. How many parameters do we have? Poisson. How many parameters? Yes, it is one parameter and it is the average value. And lambda is mean of Poisson distribution. And what is mean of binomial distribution? Mean of binomial distribution is NP. So lambda is equated to NP, because when we convert binomial to Poisson, we need lambda, the parametric value, which is taken as n into p. So your n is 50 and p is 0.02. So 50 into 0.02 will be, what is the value? It is 1, isn't it? 50 into 0.02. Now take lambda as 1 and solve the sum. So the first question is, find the probability that a box containing 50 thermometers contain no defective ones. No defective ones. So probability, no defectives. No defectives. So what is the value taken by x? No defectives. What is the value taken by x? Yes. What is NP0, Nichelle? Okay. So x is equal to 0. X is equal to 0. So e power, write the mass function. Mass function carries marks, e power minus lambda, lambda power x by x factorial. X takes values 0, 1 to infinity. So e power 1, 1 power 0 by 0 factorial. So e power minus 1. So read the value from the table for lambda is equals to 1 and substitute. Okay, that will be the answer. The second question what they are asking here is, among 1,000 such boxes, so there are 1,000 boxes given to you, capital N will be 1,000. How many contain exactly 2 defective thermometers? So for x is equal to 2, it will be e power minus 1, 1 power 2 by 2 factorial. So e power minus 1 is read from the table, Poisson table. 1 square is 1, 2 factorial is 2. Substitute, multiply and divide. You will get some probability. And into 1000 will give you the number of boxes. Into 1000 will give you the number of boxes out of 1000 boxes to contain 2 defective thermometers. Okay, 2 defective thermometers. Is that clear? Any doubt? Okay. We'll move on to the next question. Next question. Okay. See the next question over there. I hope you're solving, students. Mean and variance of normal distribution are 20 and 9 respectively. Mean and variance are 20 and 9. Find Q1, Q2 and Q3. Mean for normal distribution. It's a 5-mark sum. Okay, any type of question they may ask. Mean and variance of a normal distribution are 20 and 9. Mean and variance. So mean is mu. Mu is given as 20. Variance is sigma square, which is given as 9 for normal distribution. They're asking you to find Q1, Q2 and Q3. What is Q1 formula? That is mu minus 0.6745 sigma. And sigma square is 9. Sigma will be 3. Substitute. 20 minus 0.6745 into 3. So you'll get the lower quartiles. Q3 will be equal to mu plus 0.6745 sigma. So that is 20 plus 0.6745 into 3. Find the answer. You will get Q3. Did you calculate? What is Q1? What is Q1? Yes? What is Q1? Are you solving? Yes, 17.79 is Q1. Okay, 17.7997. What is Q3? Q3, 20 plus the product. What is Q3? Q3 will be 20 plus 0.6745 into 3. What is the value? 20 plus 0.6745 into 3. So it is 22.02. Yes, 22.02. Yes, Nichelle. They're asking us to find Q2. Q2 is nothing but median, second quartile. How do you find? Median is equals to, what is the relation between lower quartile, upper quartile and the median? Median is equals to, so if suppose I take a distribution, when the data is given, there will be a minimum value, there will be a maximum value, right? Whenever any data is given to us, maybe heights, weights, marks, any data, okay? Then median will be the middlemost value. Then we have the first quartile Q1. We have the third quartile Q3. So median is nothing but the second quartile. So how to find median based on the quartiles? It is Q1 plus Q3 by 2, the average. Average of the upper and the lower quartile. So what is Q2, the median? What is Q2? Q2 will be 22.02 plus 17.97 by 2. Okay. So find that answer. Median. So they are asking us to find Q1, Q2 and Q3. Okay. Next question. Just tell me the distribution for the next one. We won't solve. It is similar kind. There are 20 marbles in a box, out of which 12 are red colored and rest are white. A child picks 6 marbles. Find the probability that he gets 4 red colored marbles. What distribution it is? Just name the distribution. It is hypergeometric distribution. Yes. Tell me what will be A. X will be number of red colored marbles because that is what they are asking us to find. A will be number of red marbles, that is 2. Okay, right. What is N? What is N? How many marbles? A child picks. How many marbles are selected? 6 marbles, right. Okay, use the mass function for X is equal to 4. Oh, that is the probability that the child gets 4 red colored marbles. Next question, question number 31. The probability that a bomb hits a target is 1/4. 4 bombs are aimed at a bridge. Find the probability that 3 bombs are hit. At most 2 bombs are hit. 2 bombs hit the target. Yes. What is the distribution? Probability that bomb hits the target is 1/4. 4 bombs are aimed. It is binomial distribution. Very good. Binomial distribution. Fraction value is given. Moreover, it is given as probability. Probability is 1/4. That is 0.25. N is given. So it is binomial distribution. X will be number of bombs hitting the target. So 3 bombs hit the target. X is equal to 3. At most 2 will be X less than or equal to 2. Okay. At most 2 less X less than or equal to 2. So it is binomial distribution. The next question, hypergeometric. I told you they may ask us to find mean and variance. Hypergeometric distribution. So what does mean? Mean is NA by A plus B. Parametric values are given. A is given, B is given, and N is also given. Correct, right. Variance. Variance is NAB, A plus B minus N, A plus B whole square, A plus B minus 1. Okay. So that is a formula. Substitute all the 3 values and find the answer. Mean and variance. Mean and variance. Okay. Yes. Next question. What is the distribution for the next one? In a certain school, 40% of the students have opted for first language Kannada. Assuming 20 teachers take sample of 4 students. How many students are taken? 4 students. How many teachers? So out of 20 teachers, capital N is given. How many teachers will report that 2 or 3 have opted for first language Kannada? What is the distribution? What is the distribution? What distribution it is? Yes, it is binomial distribution. Yes, it is binomial distribution. What is N? What is N? I told you, define X. Name the distribution. This carries 1 mark with the parametric values given to us. In this case, how many students? 4 students are selected. P is a probability of students who have opted for Kannada language, first language Kannada, that is 40%, 0.4, and Q will be 0.6. So this carries 1 mark. Write the mass function P of X, that is NCX, P power X, Q power N minus X, along with the range, that is 0, 1 to N. So this carries 1 mark. Then the probability. Okay, probability. So 2 or 3 have opted for first language Kannada. So it is binomial distribution. Once you get the probability, 2 or 3. 2 or 3 means X is equal to 2 or, so plus X is equal to 3. Use the mass function. That is 4C2, 0.4 to the power 2, 0.6 to the power 4 minus 2 is 2, plus 4C3, 0.4 to the power 3, 0.6 to the power 4 minus 3. So get the answer. Find the answer. Then find the number of teachers who will report that 2 or 3 students have opted for first language Kannada. That is multiplied the probability by 20. Multiply that probability by 20, you will get the answer. Any doubt? Any doubt? Yes, so we'll move on to the next question. I think the last one. Okay. In a textbook, on an average, 0.3 mistakes per page is found. On an average. If there are 500 such pages in that textbook, in how many pages will there be at most 2 mistakes? What distribution it is? It is Poisson, average, 3 mistakes. On an average, 3 mistakes. It is not Poisson. It is Poisson, not binomial. Shivu, I told you. If n is given, the sample size n is given, then it will be either binomial or hypergeometric. In this case, whenever an average value or a mean value is given, it is Poisson distribution. It is Poisson distribution with only parameter lambda. Lambda is 0.3 in this case. Capital N, total number of pages is 500. Once you get the probability, you have to multiply the probability, respective probability, whatever you get by 500. Okay, so your mass function will be e power minus lambda, lambda power x by x factorial. In this case, your lambda is 0.3, e power 0.3, 0.3 power x, at most 2, no? At most 2 means x will be less than or equal to 2. So x takes values 0 or 1 or 2. Okay, less than or equal to 2. So our range starts from 0 for Poisson, 0, 1 to infinity. So x will be the 0, 1 or 2. So thrice you are using the mass function. Once for x is equal to 1, 0, then 1, and then it is 2. Okay. So we'll move on to normal distribution. Do you want me to discuss normal distribution sums? Question number 37 is always from normal distribution, which is very, very, very important, normal distribution. So I hope there is no doubt regarding binomial, Poisson, and hypergeometric. So we have discussed question number 31 and 32. I hope that under section C, you will be able to solve question number 31 and 32. Isn't it? Yes. Do you want me to discuss sums from normal distribution? Yes, dear students. That is question number 37. Yes. Okay. Question number 37. Yes. Question number 37. Shivu. Yes. Question number 37. Weights of 1,000 students are normally distributed with mean 55 and SD 3 kg. Find the number of students with weight between 57 and 60 kg. So whenever question number 37 is given to us, as I told you, it is always normal distribution. And moreover, even in the question, they will mention it is normally distributed. And normal distribution is used for continuous random variable. Okay. And the variable of interest is weights. They have given us weights. So weights follows normal distribution. So our x will be, it is obtained by, there are 2 types of variable, isn't it? Statistically speaking, variables can be categorized into 2, discrete variable and continuous variable. Right? Discrete variable is obtained by counting process. We count and write. And continuous variable is obtained by measuring process. Okay, we measure and write. And it takes any value when a range is given. So height, weight can be say 40, it can be 40.8, it can be 40.2, it can be 50, it can be any value. So it is a continuous random variable. And whenever continuous random variable is given, normal distribution is the distribution that is considered for most of the continuous random variable. So our x in this case is not number, x will be the variable weights. weights of students in this case. Weights of students. So name the distribution. This carries marks. It is normally distributed. So the notation is capital N, mu, comma, sigma square. So the Greek letter mu is for mean and the Greek letter sigma square is for variance. So write the parametric values. Mu mean. What is the mean given to you? It is 55 kgs. And standard deviation is given to us. Standard deviation is sigma. Sigma is given as 3. Okay. Now, unlike our discrete distributions where we make use of the mass functions in order to get the probability, whenever a continuous distribution is given, we cannot use the mass functions to get density functions, to get the answer. Okay, we have to standardize the normal distribution and then find the probability with the help of normal distribution table and with the help of the curve. Okay, so let us write the standard normal variate Z. This carries 1 mark. What is the formula? How do we standardize? How do we standardize a normal variable? What is the formula for Z? That carries 1 mark. So this carries 1 mark. What is the formula for Z? Yes? Are you tired? Dear students. What is Z? Z is defined as x minus mu by sigma. X minus mu by sigma. This follows standard normal distribution. Notation will be same, capital N, with mean 0 and variance 1. With mean 0 and variance 1. So we standardize the normally distributed variable into standard normal variable and then find the probability. So what is the probability that they are asking? So probability weight lies between 57 and 60 kg. Weight lies between 57 and 60 kg. So 57 is less than 60. So your left hand symbol less. Okay, so this symbol left, when it is greater, it will be right hand symbol. Okay, left L. So that is how you can remember left L. So less than, between. Okay, so 57 is less than 60. Okay, so now you have to standardize. Okay, so here we can write this as Z is equal to x minus mu. What is mu given as 55? Divided by sigma is given as 3. This follows normal 0, 1, standard normal distribution. Yes. Now you should standardize the values given to you. Okay. So 57 is given to us minus mu. We have to standardize using this method. So minus mu by sigma. Minus mu by sigma. Minus mu by sigma. So 57 minus mu is 55 by sigma is 3 less than x minus 55 by 3 less than 60 minus 55 by 3. Okay, 60 minus 55 by 3. Can you get me the value, students? Can you tell me what is 57 minus 55 by 3? What is 57 minus 55 by 3? I hope you are there. Yes? What is 57 minus 55 by 3? Okay. Savitri, I'll write the value. I won't calculate. I hope it is correct. Is it 0.66? Others? Less than Z, less than. What is 60 minus 55 by 3? What is 60 minus 55 by 3? Yes. 1.66. 1.66 or 1.67. Is it recurring? Is it recurring? Savitri, is it recurring? Yes or no? So 6 can be taken as, yes, so 6 can be taken as 6.7. Okay, we'll take it as 6.7. Yes, we'll take it as 6.7. Now what do we do? usually we draw the curve, normal curve. Okay, we draw the normal curve. A bell-shaped curve doesn't carry any mark in the exam. It is just a medium to find the answer. Okay, okay. So it is 0.67. 0.67. Both the values are positive. So it falls to the right side of the curve, to your right side of the curve, your right side. So 0.67 to 1.67, somewhere. Okay, 0.67 to 0.17. So our answer lies here. Okay, our answer lies there. 0.67 to 0.167, 1.67. Okay. Now here, in this case, whenever it is normal distribution, dear students, if the left side of the curve, left side, your left, okay, left side of the curve is unshaded, left side of the curve is unshaded, we assume that that portion is not there. We don't consider because our answer doesn't lie there. So that much area is not required. Okay. So we don't consider this. We assume that it is not there. We assume that it is not there. Don't strike out. Okay. We assume that that is not there. Now the area that is available in our hand is from 0.67 to infinity. Okay. So that is the area that is available, 0.67 to infinity. And we are interested in this area because our answer lies there, here. So this right tail that is unshaded is not required. So this tail is not required. So we have to remove it. So put in the words, area from 0.67 to infinity. Sorry. From that remaining area, you have to remove the right tail that is from 1.67 to infinity. So this portion is removed. Okay. So that we are left out with 0.67 to 1.67. I hope I'm clear. Now we have what is called as the normal distribution table. Normal distribution table where we read the area for z to infinity. Okay. Our z is 0.67, 0.67 and 1.67. So it is 0.67 to 1.67. So when you draw the curve, bell-shaped curve, 0.67 to 1.67. So it is this area. So where our answer lies. So this portion is not required. This is removed. Okay. So it is 0.67. That is 0.2514 minus. We are removing this area. Okay. This portion. So that is 1.67. 1.6 under 7. That is 0.0475. So you subtract and find the answer. What is the answer? 0.239. So your answer will be 0.2039. If suppose the question is to find the percentage, then multiply this answer by 100. Okay. If it is to find some number, as in this case, they are asking you to find out of 1000 students, number of students whose weight fall between 57 and 60 kg. So you have to multiply by 1000. 1000, therefore, number of students will be, expected number of students will be 1000 into 0.2039, that is 203.9, that is 204 students. 204 students. See how beautiful the sum is. Using the normal distribution, when the data is given regarding weights, where the mean weight is given to us and the standard deviation is given to you, variation from the mean value, They are asking us to find what is our expectation that out of 1000 students selected, the selected students weight fall in between 57 and 60 kgs. So among 1000, based on this data, you can expect 204 students. I suppose I'm clear. Is that clear? Is that clear? Okay, we shall solve one more sum. We shall solve one more sum. Okay, next question. Weekly wages of workers are normally distributed with mean 3000 and standard deviation 500. Remember, sometimes instead of standard deviation, variance can be given. Be careful in the exam. So when variance is given, take root, because we need, whenever we standardized, it is the standard deviation sigma that is used, not the variance. Okay, take root and substitute. So again, even in this case, our x will be, what is the data about? Yes, dear students. What is the data about? What is the information about? It is about weekly wages. It is about weekly wages, and see, it is given normally distributed. Okay, question number 37. Weekly wages. So this follows normal distribution with mean, mu, and variance sigma square. What is mean wage given as? What is mean wage? Mean is 3000. Standard deviation is 500. Okay, standard deviation will be 500. So they are asking you to find the probability that more than 3400 and between 2500 and 3500. So standardize the distribution. So x minus mu by sigma, that is x minus 3000 divided by 500. This follows standard normal distribution with mean 0 and variance 1. Okay, now let us find the probability. So probability x more than more. Less will be left hand, more will be right hand. So more than 3400. So standardize. Without standardizing, we cannot find the probability. Whenever normal distribution sums are given, you have to standardize it. That is x minus mu divided by sigma greater than 3400 minus 3000 divided by 500. Okay. So probability, this is nothing but z greater than 3400 minus 3000 by 500. What is the value? What is 3400 minus 3000 divided by 500? Yes? Are you there? Yes, 0.8. 0.8. So now z is greater than 0.8. 0 minus infinity plus infinity. 0.8 is a positive value, again to the right side. Greater. I told you, less means your left side. Greater means to your right side. So we have to shade the entire right side. Entire right side. So as I told you, if the curve is unshaded in the beginning to the left side, it is assumed that it is not there. It is not required. So we don't consider it. Now, towards the right, if there is any unshaded portion, you have to remove it. That is subtracting. Okay. So in this case, the area of interest will be area from 0.8 to infinity. 0.8 to infinity. So this portion is assumed to be, this portion is not there. Okay, we don't consider because our answer doesn't lie over there. So it is not there. So it is 0.8 to infinity. So whenever it ends with an infinity, we refer to the table. It should end with an infinity. Okay, then only we can refer the table. So 0.8. So go for the table, normal distribution table. 0.8 is a positive value for z. 0.8 under 0 will be 0.219. 0.219. 0.2119. So our answer is 0.2119. 0.211. So they're asking us to find the probability, not to find any expectation or percentage. So that will be the answer. So now it is between 2,500 and 3,500. Okay. 2,500 and 3,500. So probability between 2,500 and 3,500. So between, so 2,500 is less than 3,500. So less, left hand less. So standardize 2,500 minus mu, that is 3,000 by 500 sigma less than, I'll write directly our x as z, less than, because when you standardize it will be z, 3,500 minus 3,000 divided by 500. Right? Okay. Now 2,500 minus 3,000 will be minus 500. 500 by 500 is minus 1. So minus 1 less than z less than plus 1. Okay. So minus 1 to plus 1. So draw the curve. Minus 1 to plus 1. It's a symmetric curve. Okay. Minus 1 to plus 1. So minus 1 to plus 1. So to the left side, minus 1. To the right, it will be plus 1. So this is the area of interest. Our answer lies here. So as I told you again, I'm repeating, towards the left, whatever shade is unshaded, it is not considered. We assume that it is not there. So what is remaining? What is remaining? So this portion is remaining. Okay, this portion. And that portion is probability area from minus 1 to plus 1. Our area of interest is this, minus 1 to plus 1. So as I told you, this portion is removed. Okay, you have to subtract this tail. Okay, so that you are left out with minus 1 to plus 1. This. So we put it in words. So probability area from, what am I doing now? From this area, remaining area, minus 1 to infinity. From there, from the remaining area. Okay, this portion is not there. This is not there. So from the remaining minus 1 to infinity, I have to subtract the area 1 to infinity. Area 1 to infinity. So I have to remove that area. So minus 1 to infinity from the table where your z is minus 1. Go for the normal table. Okay. So z, you can see z is negative here. Our z is minus 1. So minus 1, the value is 0.8413. Substitute 0.8313 minus 1. What is the value when z is 1? 8413. 1. When it is 1, it is 0.1587 from the table. Okay. 0.1587. So 0.1587. Correct. Thank you, Michelle. So is this 8413? Just check. Minus 1. When z is minus 1. Yes. Okay. So what's the difference? What is the difference? 8413 minus 0.6826. So that is how we find the probabilities for a normal distribution. Now, if suppose the curve is something like this, okay, just let us discuss all the possibilities of the curves. Okay, and let me say that the value is from, okay, your z is, once you standardize, your z is, say, z less than minus 2. Okay, z is less than minus 2. I'm taking a random number, minus 2. So minus 2 lies to the left side. Negative values lies to the left side. Less than. As I told you, less is for the left hand. So your left side you should shade. The entire left is shaded. From that -2. So this is the area of interest. Our answer lies here. So in the beginning, I told you while solving two sums that whenever the left side is unshaded, we assume that that area is or not available or it is not required. But in this case, the entire left is shaded. So how do we find the area? To the right side, if there is unshaded tail, we remove that tail. That is, we subtract. Mathematically, we subtract that area. Okay. But when the left tail is shaded, entire left is shaded, you have to consider the entire curve. If the curve is of this kind, you have to consider the entire curve. And it will be from the entire curve, you have to remove the right tail of the probability curve. Okay. So this tail is removed, right side. So in words, if I have to write, it is probability area from the entire curve, area from -infinity to +infinity, minus probability area from -2 to infinity. So what is the total area under the curve, -infinity to +infinity? May I know the total area under the curve? What is the total area under the curve? Yes? What is the total area under the curve? 1. Yes. 1 minus, correct, 1 minus 2 to infinity. Now z is -2. Can you read the table value and tell me? -2. Yes? The active participants. -2. 0.9772. So that difference will give you the probability. Okay? -infinity to +infinity, from -2 to infinity. Is that clear? Is that clear? Yes? Okay. I hope the sums from theoretical distribution, may it be binomial, Poisson, hypergeometric, and normal distribution. There is no doubt. Is there any doubt? I think I have given equal justification for all the 4 distributions, isn't it? Yes? Is there any doubt? Any doubt in this chapter? Theoretical distribution. So I have discussed question number 31, question number 32, and question number 37 from the question paper. Okay, all the 3 sums are for 5 marks. Is there any doubt? Is there any doubt? No, okay. So we shall come back to the model paper. Okay. Yes, sorry for that interruption. Okay, so going to question number 33. Question number 33 and 34 is from the chapter test statistics. That is statistical inference. Is from statistical inference. Now, question number 34, 33, and 34, as I told you, under statistical inference, altogether we have 3 concepts that you have studied. That is large sample test, small sample test. Okay, I won't solve the sum today. Okay, we shall discuss in the next session. But let us see. Let me discuss few points. Okay, from that is for question number 33 and 34. That is from the inference chapter statistical inference. So we have large sample test, small sample test, and chi-square test. Okay. chi-square test. Now, large sample test. How many formulas did you study under large sample test? 4 formulas, yes. So, 4 applications we can say. What are the 4 applications? Now, why do we say it as a large sample test? When any information is given, what is the difference between large sample test and small sample test? What sample size is considered as large? Yes, if n is greater than 30, if n is greater than 30, okay, it is statistical inference. So, if n is greater than 30, it is a large sample test. If n is less than 30, less than or equal to 30, it is small sample test. Yes, small sample test. Now, under large sample test, what is the distribution that we use? If the sample size is large, more than 30, what is the distribution? What is the distribution that we consider? It is normal distribution. And if the sample size is less than 30, if it is small sample, what is the distribution that we consider? What is the distribution that we consider if it is small sample? Yes? Small sample. It is not binomial. It is T distribution. Okay, it is T distribution. It is T distribution. So when the sample size is large, we go for normal distribution and Z test is used. And when it is small sample, if the sample size is small, we go for T distribution and T test. Savitri, is that clear? T test. Now again, there are 4 applications of Z test. That is testing for significance of mean, population mean. We test for mean value, single mean, and when 2 means are given, difference between the means. And then we have test for proportion, population proportion. Then we have difference in the proportion. Okay. So we have x bar minus mu by sigma by root n. Then we have x bar 1 minus x bar 2 by root of sigma 1 square n1 plus sigma 2 square by n2. Difference between the means. We have proportion test, population proportion. So it is P minus P naught divided by root of P naught Q naught by N. So standard normal distribution, Z test. And then we have difference between the proportion. When 2 populations are given, it will be P1 minus P2 divided by root of P hat Q hat 1 by N1 plus 1 by N2. Standard normal distribution, Z test, where P hat will be N1 P1 plus N2 P2 by N1 plus N2, or it can be X1 plus X2 by N1 plus N2. Okay, so these are the 4 application of Z test to test for the significant difference in the mean, in the population mean, difference between the means, population proportion, and difference between the population proportions given to us. T test or T distribution, we have 3 formulas. Single mean, it will be x bar minus mu naught by S by root n minus 1. This follows T with n minus 1 degrees of freedom. Or it can be x bar 1 minus x bar 2 by root of SC square combined variance. What is the definition of critical region? Lakshmikant, critical region, see, whenever we test a value, critical region is also known as rejection region. There is a question by Lakshmi Khan, minus infinity to plus infinity. So if it is Z test, I'm telling, we draw the normal curve. Okay. And as I told you, critical region is nothing but the rejection region. Now, critical region is a region which will lead to the rejection of the null hypothesis. Whenever you conduct any of the tests, whenever there is uncertainty in accepting any statement, and we want to test whether to accept that statement or to reject that statement, we usually go to the concept of statistical inference whenever we have to take decisions regarding uncertainty of the occurrences. Then, if suppose it is Z test, we draw the normal curve. And as I told you, critical region is the rejection region. It is the area or the region of the probability curve of the null distribution. The curve what you draw is called as probability curve, and it is for the null hypothesis, okay, which leads to the rejection of the null hypothesis. The test is always conducted to test the null hypothesis H naught. I hope it is clear what is critical region. Is that clear? It is a region that leads to the rejection of null hypothesis. Yes? Yes, okay. So rejection region can be one-tailed or two-tailed. Okay? It can be one-tailed or two-tailed, depending on the hypothesis, whatever we are testing. Yes. So I was telling about T distribution, T test. So we have x bar minus mu naught by S by root n minus 1, and T is equal to x bar 1 minus x bar 2, root of SC square by 1 by n1 plus 1 by n2, where the degrees of freedom will be n1 plus n2 minus 2. And then we have paired T test. Okay, paired T test. That is d bar by sd by root n minus 1. Whenever the observations are paired, we go for paired T test. So these are the 7 formulas. When it is small sample and large sample, that is when we test for mean, we have 4 formulas. Okay, we have to test a single mean, we have x bar minus mu naught by sigma by root n. If it is small sample, we have T test. If 2 sets of data is given, if 2 means are given, again we have 2 sets of formulas. Okay, there you have to check whether the sample size is large or small. If it is large, go for Z test. If it is small, go for T test. Okay. If suppose paired observations are given and you are testing for the mean value, and how the data will be, usually whenever paired T test is given, your data will be related data, correlated observations will be given. That is before and after data will be given in most of the cases. And whenever in the question paper, if you see a data where before and after is given, that is before marks scored by the student, variables will be given. Only chi-square test is for attributes. Okay. Mean test is for the measurable quantity. Under mean Z test, we have proportion test, which is again for attributes. Okay. Proportion test is for attributes, qualitative data. Mean test is for variables. So I don't have to tell. Okay. Whenever before and after data is given, we go for T test. Okay. Paired T test, before coaching, after coaching. Blood pressure of the patients before yoga, after yoga. So when such data is given, it is always paired T test. Okay. And if in the question, if there are words like say mean, that is for question number 33 and 34, I'm telling. 33, 34, and also question number, Roman number 7, question number 38. Question number 38. Yes, question number 38. So question number 33, 34, and 38. These three questions will be from inference. Okay, it is from inference. If there is word mean, then it is mean test. You have 4 formulas. Check whether the sample size is more than 30 or less than 30. If it is more than 30, Z test. If it is less than 30, T test. If the data is before and after, it is paired T test. Okay, it will be paired T test. Paired T test. If proportions are given, percentage values are given, then it is proportion test. Proportion, percentage, point values are given, it will be proportion test. Okay, again Z test, proportion test. Then we have chi-square test. Okay, we have chi-square test, that is for attributes. How many formulas do we have? Chi-square. What are the 3 application of chi-square test? We have 3. We test for independence of attributes. Okay, independence of attributes. Then we have test for variance, correct. Chi-square test for variance. Then test for goodness of fit. Yes, goodness of fit. So these are the 3 applications for chi-square test. All these questions are important for 2 marks. Application of chi-square distribution, application of T distribution. Okay. So we shall discuss the sums in the next class, dear students. That is question number 33, 34, and 38. So altogether 10 formulas. Out of the 10 formulas, any 3 could be asked in the exam. So shall we discuss in the next class? Yes. So if there is any doubt in any other chapters, kindly make a note of it so that you can clarify your doubts. Is there any doubt regarding whatever we have discussed in today's session? Was there any doubt? Do you need any clarification regarding the concepts that we discussed today? Yes? Yes, students. I hope today's session will be helpful to you in scoring good marks. Could you follow whatever was explained? Yes. Okay. Thank you. If there is anything that you want to ask related to the subject, you can ask. We have 5 minutes. And if there is no doubt, we shall wind up. How was the session? Yes? How was it? Good. Okay. What about others? Yes, students? I hope more participants will be there for the next session. Yes, thank you. We shall wind up and meet you in the next session, that is on Tuesday. Okay, yes. Thank you so much.